All right. Hello, everybody, and thank you for attending this seminar. In this presentation, we will be talking about the universal input connector that is being developed for the OpenRack V3 PowerShelf. My name is Will Stewart. I am the Industry Segment Manager for Data Centers with Harding, and with me is Nitesh.
Hi, this is Nitesh Kanan. I'm from Positronic. I'm a Global Product Manager. Nice to meet you all.
Cool. Today, we will talk about the OpenRack V2 power architecture, how that's going to change to the V3 power architecture. We'll look at a case study of an OCP member that successfully implemented the connectorization change. We'll talk about the joint development agreement that the connector manufacturers signed together in order to develop this connector. And then Nitesh will talk about the specific features that will be featured on this new connector that we've developed. So to start, in the OpenRack V2 power architecture, you have electricity, the power that comes into the data center through the ATS, through the various distribution panels, and then eventually winds up on the busway. That busway has a cable drop, which goes down to the GPDU. Now, the cable that enters the PDU is what we call gets hardwired into the PDU, which means that the cable actually lands on terminal blocks inside of the PDU, and it's therefore fixed. That means that depending on which cable is in the drop from the busway, which could be a IEC 309, it could be a California standard, or a NEMA plug, the PDU that you need gets tied to that specific connector. From the PDU, you then go down to the power shelf, and in the power shelf, we have a few different SKUs as well for the varying power densities. So whatever amperage you need your power shelf to run at, you need to pick the specific SKU that can be appropriate for that architecture. Now in V3, what we're going to do is we're going to get rid of the PDU completely, and we're going to cable directly from the busway into the power shelf. Not only that, but we're going to make one universal power shelf that can be used globally. In order to accomplish that, what we need to do is we need to separate the power shelf from the cable so that the cable can be sourced per the connector that's on the drop from the busway. And in order to make that cable, you need a connector on the power shelf. That connector is what we're talking about in this presentation. So why do we need to do this? What's wrong with having so many SKUs to be able to account for each individual power level and each individual international destination that this is going to be implemented? Well, first off, it prevents effective inventory management. And what I mean by that is you literally can't keep an inventory of all of these SKUs. If your data center operator is using 4 or 5 different PowerShelf SKUs, you can't hold stock of just one. You can't keep a safety stock because you don't know what's going to be used next. If there's just one universal architecture, now you can hold a safety stock and cut your lead times down, et cetera. The second is actually on the operational side. Just sourcing one power shelf, it doesn't take long to, make sure you pick the right one. When you implement tens of thousands of power shelves per year, then it starts to take a while in order to be able to make sure that you're selecting the right one. And just having one SKU really cleans that up. The second part is that when the cable is hardwired into the PDU, when you refresh your data hall, you now need to get rid of that cable as well. Whereas if the cable is connectorized, you can keep the cable at the data center, and then you are saving more money on the refresh. So now I want to talk about a case study of an OCP member that implemented this effectively. I'm talking about Microsoft and their Project Olympus program. They use a Harding connector on their PDU in order to separate the cable from the PDU. and see all of those benefits that I just talked about on the previous slide. They saw their lead time on their PDUs drop by 75%, about 6 weeks. The power cables can be reused or can be updated outside of the PDU. And again, now they have global stock, a global inventory, and a much simplified supply chain, which again added to them dropping their lead times. But there's a technical challenges with actually implementing this connector. Number one is the space in between the back of the power shelf and the back of the rack is not a lot. And so when we talk about a universal power shelf, we obviously need to design it to the highest amperage that it's rated for, which means that you need to design it for the thickest cable, and the cable has to be able to bend successfully through the power rack, or through the open rack, in order to plug into the power shelf. So just a limited space with high amperage, and also we want to still make sure it's safe. So in order to do this, we decided to get all of the connector manufacturers together to be able to join forces and design the best connector for this application. And how we did it is, starting last summer, we had the participating companies sign a JDA, a joint development agreement. In July, we had our initial meeting out in Menlo Park. We were able to decide on an interface in October 2019, and the first prototypes were developed at the beginning of this year. So now to talk about the actual connector itself, I'm going to pass it over to Nitesh.
Thanks, Will. Thanks for setting up the nice, the initial stage for this. So yeah, now we're going to talk about the details of the connector, like what Will mentioned. We formed a joint development, it's a group, and then we group of us, we started to develop this connector. So we have faced a lot of things, related when we design this, and he already talked about the technical challenges, and then so we're going to see the technical challenges and what's the scope and what's the rough design overview of this connector and some of the key features of this connector, and what's the timeline and when this connector is going to be available for all of you. So this is what I'm going to talk today, and let's talk about into the details. So here we go, and look at this image, and then we can realize, it's skewed, but actually that's the biggest challenges is like the size. But what Will mentioned, the space is very limited, so we have to skew the connector into that space with the higher amperage, the higher voltage, and plus we need to have some modularity within the connectors. That means people need to have some flexibility in terms of the design. So we need to have that feature as well. And plus, most important, there's a power efficiency, and then we also try to minimize the skews actually. So these are all some of the challenges we face, and let's go into the scope. Actually, this connector is basically, it's a 7-pin input connector with the 3 inputs and 3 returns and 1 ground. And it's a universal. A female is a universal with a snap lock, and the male connector could be straight or right angle PCB board mount. And the connector cater for flexible termination length to cater for different PCB thickness. So in terms of PCB thickness, the contact tail length, that's what we call in our terms. It can be adjusted based on the PCB thickness of the manufacturer. So that should have that flexibility. And the male and female connector to meet the UL finger touch proof, and then the voltage. This is a voltage rating. 380 VDC and then 480 VAC, and it has some multiple accessories options for crimp, stride, or right angle, board mount, and everything. And crimp contact supports the wire gauge from 12 AWG through 8 AWG. So, and the last but not least, and this is the challenge, the connector has to fit within the trough of 23 millimeters. So this is basically the scope. And with that, you can see this is it's a nice image of the of the the shelf, power shelf from the rear side. And thanks to Steve and his team here, they did this. They rendered this image for me. So if you look at these two, there are two connectors on the back of this. So one you can see. So and you know that we need two different connectors. That means two different metal pads. So if you talk about in terms of so we as a positronic, we actually been with the OCP for quite a while from the V1. So we have the open rack V1. It's our positronic connector has been designed, and it's the same thing, but it's a three pin size 12 contacts, what we call. And this, you can look at the power current is 50 amps for the max, and then 30-degree rise for the 35 amps. And if you come back to the V2 also using the same positronic has been providing this solution with 5 position. This is a 5-pin size 12 contacts. And then V3. So V3 we came up with. We'll be glad to offer the solution. This is a size 8 contacts, which is very higher voltage configuration, and the current rating can be 80 amp max. But actually, what we are targeting for 30-degree rise is 50 amps. But in the spec we have it's the limiter about 30 amps only, but it can have capable of carrying 50 amps. The key thing, if you note from this, is the initial contact resistance. So what actually we came up with is positronic has a very unique product which is called Scorpion series. So that's what in the V2 also the same Scorpion series. So this for this universal AC input connector, we came up with the same modular concept. So what does mean by modular concept? If you look at this, each being separated by the mod, each are what we call modules. So this is the N modules on the left and right, what we call N modules, and these are all the contact modules. So basically, what is, you can have an option of choosing your own different options with the accessories, but even this one what we call modular the contact models. So we can have a cable crimp, or you can have a straight PCB, or you can have right angle PCB. So you can choose what you want. So it's basically you can build our own connector. So this is a come as a perfect fit for this universal input connector. So we call, like I said, is the N model and the contact models, and this. So this is, if you look at closer look about the same, the power shelf into the where the connector is going in. So what we call a left and right connector. So right connector and left connector, it's let's say the male side. Basically it's the same insulator, but what we call inverted bending. So just flip the connector and then do this. It's a two different SKUs on the male side. But if you look at the female side, the cable side, the female cable side is a single SKU. It's a single port number, but the same connector is capable of mating both male connectors. So that what does mean is you can just flip through and rotate it, and then you can mate on the other side of the left side connector and the right side connector. It's the same single female connector. And which has, what helps in this, the wiring configuration, we have 3-phase capable of, like I said, even the configuration you can do some different configuration, 3-phase 5-wire in star connection, 3-phase 4-wire in delta connection, and can be single-phase 3-wire connection. And these are all the information will be on the spec. So the spec has a clear information on how you can configure the wiring configuration. So if you look at the termination, this connector can be, like you mentioned, it's modular. So you can have a right angle, and you can have a straight, and you can have a complete crimp with a panel mount, or you can have a mix of PCB, board mount, and then crimp. So it has complete flexibility of that. This connector will have the flexibility. So, but we just now we talk about the male is singles. The male is insulator is same, but we have a different way of configuring it by left and right. But the female is a single connector. So how we can achieve this, to mismate on the other side, is by individually polarizing the each male position, male contact. I would say male contact. So if you look at the right, you can see the polarization is on the top, And if you can see the left connector, the polarization at the bottom. So the female is just follow the same way, you can flip. So you can go the other side and then mate. So that's individually polarized. These two connectors are individually polarized. And this is what I call the grounding and finger touch shape. The middle, the center one is, it's a grounding purpose. So you can see the kind of sequential mating, and it's a UL 1977 finger touch proof. So it has a male, female is naturally is touch proof, and then male we have a special cap on it to make it touch proof. And this is the connectors with the different PCB board mount accessories. What it mean by board mount accessories? If you the first left on the left side first one is called a threaded insert. So this is it's a metal threaded insert onto the insulator, so you can mount onto the PCB directly. This is one option again. And on the right side, what we call a PCB mount with the angle bracket. So if you look at the angle bracket and the tip of the angle bracket, there is some kind of latch on it, so you can just press and lock itself onto the PCB. And same thing, you can have a straight self-tapping screw or push and fastener. So these are all options available, and you can choose what you want. Actually, it's all in the spec again. This is basically the dimension, roughly the male and female connector. This is what's going to be the dimension. We had a challenge to achieve this, the height, which is the trough is 23 millimeters, so now it's 18.6. So that's the challenge. The cable exit is about 45-degree exit cable. And look at the male connector, and this is what I talked about. Is another feature, another kind of flexibility is the male contact has a different termination length is based on your PCB thickness. So if you have your PCB thickness is more, so you can request for more different termination length, so it can be configurable, no problem. And then the project timeline wise, so we already, like what we'll mention, the soft tooling prototypes already built and already sent, and then right now the testing is going on. So we received some initial feedback about some of the design, and then the ORV3 spec, it will be released by end of May or before that, or during our summit, once the spec is released. And the production tooling, the prototypes with the actual production tooling, so it will be on the August, and the verification and validation to be completed by the end November. So that's what we are targeting to be fully released. It will be, so by end of this year you can have a full qualified connectors with all the tests, and you can have a spec. If you want to review, you can have a spec and you can review, and call to action. So these are all some of the links that we would like you to visit, and then if you are interested, this is the spec is available on this link. And then if you want to have an open rack project information, there is Rack and Power wikis available. You can you can up to date, and you can subscribe to the mail list if you want for the Rack and Power, and the Rack and Power mail list you can see from this link as well. So we would like all of you great mind to come and share. So let's make together, we use the OCP as a platform, and let's make the world great. And so the final note, thank you so much. So like I want to say that technology alone does not build the enterprise, but relationship do. So don't build links, build relationships through this excellent OCP platform. Thank you very much.
Hi guys. I saw a question
Hello.
about how's the connector attached to the PCB, solder or press feed. There are different terminations available. Even it can be stride or right angle, press feed or solder. Different things or different type of terminations are available, and even panel mount. Panel mount, the cable version is also available on the mill side.
And then Eric Fishcorn asked, will the connectors intermate? And is the timing listed for positronic and Harding? The connectors absolutely will intermate. That's the main point of our meetings. And the timing was for positronic, but Harding projects to have our production up and running. We'll have samples in about 6 weeks, and our production will be up and running towards the end of this year. And then Josiah asked, how was the strain relief for the cable handled? It looks like the cable wires are coming directly out of the connector housing, or are those laminated bars that join the cable? So for this, I'm actually not positive how Positronic is doing it, but Harding's will have an overmold there that can hold everything together. So there's an overmold in the Positronic or in the Harding solution.
For that strain relief, there are two options we are proposing right now. One is we have a back shell and cable tie option, but we are looking into the a metal cable clamp strain relief as well. We have a flexibility to do the just a crimping and then assemble the cable assembly. Mm-hmm. Why the key connectors for the top feed or bottom feed?
Yeah, so Natasha, Jared, this was a requirement that came to us that was discussed in the group. And in the group, we do have power shelf manufacturers as well. And it's the requirement was that we should key the connector. So we made a keyed connector. I can't really speak to how the PSUs are handling it on the other end. And then there is 3D models available. There is a Google Drive for the Rack and Power subgroup, and it's available through that. So you can reach out to Natasha or me, or the Rack and Power chairs, Caleb Lusk and Hamid Kenyani. Yes, we certainly hope that this is a flexible solution.
So, yeah. What Jeff is mentioning that.
Mm-hmm. Thanks. Thank you, Ralph. Okay, cool. So it looks like the questions have stopped. So thank you, everybody, for joining. We're really excited about this moving forward. And good job, Natasha.
Thanks, guys. Thanks, Will. Yeah. Say anything, let us know. Okay, you can reach us, and we can. The spec will be available soon. The samples are already giving out to the partners like Artisan, Delta, and Light on all these people, so they are already reviewing. Thanks, everybody.
Thanks, everybody.